This video explains how virtual DOM diffing works. The performance concepts diagrammed in this video will be useful when understanding how change propagation works in the next video. The example we will be using is showing a filtered list of completed to-dos from a source list of all to-dos. We'll be changing jump to complete and want the completed list and the DOM to update accordingly. On a high level, VDOM diffing works by first refiltering the source list into a new derived list, then building a new virtual DOM from the source list, then it builds a patch by taking a difference between the old virtual DOM and the new one, and then finally applies those changes to the DOM. Let's see how this works specifically. Notice that we've started with our source list of to-dos, our derived completed list of to-dos, the VDOM created from the completed list of to-dos, and the DOM as it stands. In the bottom right, we'll track a theoretical cost of each operation. We'll say that changes in object land cost 1 unit, while DOM changes cost 10 units. So the first thing that happens is the source list of to-do changes. Jump is marked as completed. Notice how cost is now 1. Next, we need to update the completed list of to-dos. The old list is discarded, and we begin refiltering the source list of to-dos. Now that we have our filtered list, we can render the virtual DOM, creating a node for each completed to-do. With our new virtual DOM, we need to identify differences between it and the old virtual DOM. This means iterating through the virtual DOMs and marking any differences. When we find a difference, we can apply that patch to the DOM and mark the new VDOM as the old VDOM so we are ready for the next change. Virtual DOM diffing with derived data takes 3 loops, so it's a linear speed algorithm. While there is unnecessary work, if the dataset is small and the operations in the DOM are expensive, it can still provide fast updates.